Welcome to qnawire.
So in this problem we have a tower here and then a cable attached here that's attached to the ground here and attached to the top of the tower here. We're told that the cable weighs or has a mass of 1/2 kilogram per meter, so we need to multiply that by G to get the weight per unit length. We know that the cable is 25 meters long, that the distance from the point where it's anchored to the ground and where it's attached to the cable, the horizontal distance here is 15 meters, and then this angle that it makes with the horizontal at point B is 30 degrees. So with all that information, we can start, writing the equations from what we had in the book. Now we know that the slope is given as a function of s, is given by this expression. And so we know at s equals 0, which we're going to call it at this point here, so s measures up the curve here. We have that the angle, the slope, has to be tangent of that angle. So that gives us one equation where we can find C1. We also know we can write down x as a function of s. That has a constant C2, and then I didn't write out the whole expression, but you can get it from the book. Plugging in s is 0, and we can then get what C2 is. And in the end, we can invert this and get s as a function of x, and that comes out to be this lengthy expression here. Now, we can also get, once we know these constants, we can also get y as a function of x, and that turns out to be this lengthy expression. Now, because we can basically plug in s as a function of x here, and then integrate, and we'll have another constant of integration, but we can find that one by using a condition at one of these boundaries. We don't know how high this is, but we also know that that y at x equals 0 should be 0. And so that will give us this constant of integration, because at x equals 0, this is 1, this is 0, so we'll get our constant of integration from that condition. Now we know that at s as a function of s, so x, so when we plug in x equals 15, we know that we should have gone 25 meters along this cable. So that will get, knowing W naught, that will give us an equation where we can find FAX, so the horizontal force in this at the upper support here. And again, we need to use some root finding or trial and error methods, but we can find it to be 73.9 newtons. So that's what the horizontal force is here. And now we can figure out, if we can also figure out the angle here, okay, or the slope here. And we know that FAY, the vertical component, is FAX times the tangent of this angle, of the angle here. And we know the tangent of that angle is the derivative dy dx at s equals 15. So we know x, we know FAX, we know C1. We can plug in s equals 15, we know W naught, and we can find that this force here is 165 newtons. And what's kind of odd in this problem, and might be a little counterintuitive, is that if you figure out what the total weight of this cable is, it is less than 165 newtons, which means that this load here is actually pulling the cable down to the ground. So we actually have a force like this holding it back, because I think basically if you think about it from intuition, is that if you let this go, this would want to kind of come in like this or like this. And so you could actually do a problem where you can say, well, what say this force here, or this force here is 0, and that would mean that the cable is actually at a 0-degree angle here, and it comes up and attaches there. So it would probably come in like more like this or something. So we have a force pulling it out, and we have also a force holding it down to make sure that it sticks at that point.